Hello, my name is Parthay Bhatt, and today I'll be doing a presentation on hybrid recommender systems. History of recommender systems. Everyone nowadays has some experience with recommender systems, whether it be a movie recommendation on Netflix or an item you might be interested in recommendation from Amazon. However, historically, people relied on recommendations from their friends and family or from experts in newspapers or on TV. This changed when there was an explosion of information available on the internet in the 1990s. It started to become increasingly difficult to review all the information available and find the ones that best meets your needs, such as going through all the items on Amazon and finding the items you were looking for, or going through the entire library of Netflix and finding the movies you were interested in. Researchers started to study this problem and came to the conclusion that information filtering tools were required to sort, prioritize, and manage this sea of information. Recommender systems are one such subset of information filtering systems that emerged in the mid-1990s. Early research. In early literature, recommender systems were defined as a system where people provide recommendation as inputs. The system then aggregates these recommendations and directs them to appropriate recipients. At present, the term has a broader definition and describes any system that outputs individualized recommendations or has the effect of guiding the user in a personalized way to interesting or useful objects in a large space of possible options. Research published in the early 1990s shows that the recommender systems stemmed from the other closely related areas of studies such as human-computer interactions, machine learning, and information retrieval. Recommender systems used by companies. These days, recommender systems are an integral part of the internet we know. Many well-known companies such as Netflix, Google, Amazon, etc. have heavily incorporated them into their businesses and constantly strive to improve them to increase profits. The research into recommender systems to make them more efficient was boosted by Netflix in 2006 when they announced a $1 million reward for a 10% improvement of their existing movie recommender system. Now almost all large websites use recommender systems to direct user to their interests and in return increase user satisfaction and profit. Recommender system methods. Recommender system methods from the reviewed literature can have several possible classifications. The classification of a method is not determined by how the user interacts with the recommender, instead the source of the data on which the recommender acts. In general, a recommender system has background data, which is the information that the recommender already has before the recommendation is made, input data, which is the information that a user must give through the recommender to generate recommendations, and an algorithm that uses the background data and the input data to generate recommendations. Previous work has classified recommender system methods into 5 groups based on the source of data: collaborative filtering, content-based filtering, demographic filtering, and knowledge-based filtering. Collaborative filtering. Collaborative filtering recommender systems are the most widely known and implemented, as well as the most mature of all recommender system methods. One of the earliest research papers on this group of recommender system defines it as collaboration between people to help one another perform filtering by recording their reactions to document they read. Collaborative filtering recommender systems work by aggregating ratings or recommendation of objects, identifying commonalities between groups of users, and generating recommendations based on these inter-user comparisons. In some systems, ratings or recommendations may be binary, such as like or dislike. In others, a range of values indicating degree of preference, such as a 1 to 5 star rating. Examples of collaborative filtering used in real life. One of the earliest recommender systems to be published was a manual collaborative filtering system called Tapestry. It allowed users to query for items in an information domain based on other users' opinions or actions. Soon after, in the mid-1990s, the first automated collaborative filtering system was published called GroupLens. GroupLens was a collaborative filtering recommender system for news, and Bellcore Video Recommender was a recommender system embedded into the Mosaic browser, popular at the time. There is an image of a GroupLens recommender system here. Advantages of collaborative filtering. An advantage suggested by literature on automated collaborative filtering recommender systems is that the user only needs to provide ratings or perform some actions. The system then combines this collected input data with similar data from other users to provide personalized recommendations. Users do not need to have direct access to other users' ratings or actions, nor do they need knowledge of every object in the system to receive a recommendation. Another advantage of collaborative filtering recommender system is that they work particularly well for complex objects such as music and movies, where there is a strong correlation between taste and preference. Content-based filtering. Content-based filtering recommender systems were a natural continuation and evolution of research after collaborative filtering methods. This group of recommender systems assumed that the user who liked objects with certain features in the past will like objects with similar features in the future. In such systems, the objects are defined by their associated features. A content-based recommender system learns a profile of the user based on the features of objects that they have rated or performed some observable action on in the past. New objects are compared with user profiles to provide recommendations. A variety of learning methods have been proposed by previous research for creating user profiles, such as decision trees and neural networks. Examples of content-based filtering. One of the first content-based filtering recommender system to be published about was Newsreader, which allowed users to rate news articles from 1 to 5 and then used words from the articles as features to learn a user profile and recommend personalized news. Fab was a similar content-based system that used 100 words with the highest TF-IDF weights as features for documents. An integral part of the content-based filtering recommender systems is learning user profile, for which Fab used Rocchio's algorithm to learn the TF-IDF vector. An article about content-based Fab can be seen in the bottom right. Advantages of content-based filtering. Content-based filtering recommender systems provide numerous advantages over other systems at the time, which propelled its research in the mid-1990s. One of the greatest advantages is the system's ability to recommend only depends on the user's rating and actions. This allows content-based filtering recommender systems to match the unique taste of every user and provide niche recommendations. The system is also scalable in terms of numbers of users in the system because the recommendations are not dependent on interest of other users, so the resources and time required to make recommendations do not increase as users in the system increase. Demographic filtering. Research into demographic filtering recommender systems followed on from content-based filtering recommender systems. Demographic filtering recommender systems aims to categorize users based on their demographic data such as age, gender, education, etc., and make recommendations based on these predefined user categories. These demographic user profiles are used to find the types of objects that the user will be interested in. The leading research into this subset of recommender systems has been in finding effective ways of collecting the demographic data from users. It is becoming increasingly difficult to automatically collect enough demographic data due to the increasing regulations surrounding user privacy. Examples of demographic filtering. The first published research paper on recommender systems was Grundy, a primitive demographic filtering recommender system that grouped users into categories based on short interviews. It recommended books by matching the collected information against a library of manually assembled user groups. Lifestyle Finder used a similar approach to categorize users into one of 62 groups from marketing research to recommend a range of products and services. The image, and you can see in the bottom right, is about Lifestyle Finder. There is not much research done on demographic filtering recommender systems on their own. They are always combined with other types of recommender systems in hybridization, so it is hard to find specific advantages. Besides that, it does not require a history of user ratings to provide recommendations. Knowledge-based filtering. Knowledge-based filtering recommender systems are different from the rest as they do not try to build long-term user profiles that are updated after user interaction. Instead, they recommend objects based on inference about user needs and preferences. While all recommender systems rely on inferences on some level, Knowledge-based filtering recommender systems are distinguished by relying on functional knowledge. This is knowledge of how a specific user need can be satisfied by an object and using this to build a relationship between user needs and objects. A subset of knowledge-based filtering recommender systems are constraint-based recommender systems that build on the research and apply to rarely bought items such as cars. Examples of knowledge-based filtering. An example of this type of system is the personal logic recommender system that requires users to do their own mapping between their needs and the features of products by answering a detailed questionnaire. The restaurant recommender and entree, the wasabi personal shopper, and doublet all have published research papers discussing their use for knowledge-based recommendations. Probably the most famous implementation of a knowledge-based filtering recommender would be Google in later 1990s and early 2000s. It used information about the link between web pages to infer the popularity of a web page and give it value. Problems of recommender systems. All types of recommender systems have their problems. Studies have tried to identify and address these problems since the very start, and continue to do so up to this day. Some propose sophisticated algorithms to solve these problems, while others suggest combining multiple recommender systems to counteract each other's problems. Most frequent problems in the study literature are cold start, accuracy, scalability, and diversity. Cold start. The cold start problem is one of the most known problems in recommender systems, and it is extensively studied in literature. It deals with sparsity of information related to users and objects available to the system to make recommendations. It is also known as the ramp-up problem and mainly affects collaborative filtering and content-based filtering recommender systems. Studies have identified three types of cold start problems: recommendation for new users, recommendation for new objects, and recommendations of new objects for new users. Why is cold start a problem? Collaborative filtering recommender systems face the problem of new users not having rated any objects, which makes it difficult for the system to compare and group them with other users with similar tastes. They also deal with the problem of having to recommend new objects added to the system when those objects do not have any ratings. Solutions to the cold start problem. A naive solution to this problem is to provide some sort of incentive to the user to rate more objects. A more sophisticated study proposes the use of probabilistic model to extract features from objects and use them to generate pseudo ratings to kickstart recommendation of new objects. Another study tries to solve the problem by combining collaborative filtering recommender systems with content-based filtering recommender systems. There is also a solution where weighted outputs of different recommendation techniques are merged using ordered weighted average. Since this is one of the more prevalent issues facing recommender systems, there is an abundance of research on it. We found a total of 23 studies in our literature review. Accuracy. It can be argued that the recommendation accuracy is of utmost importance in any kind of recommender system. It is the ability of a recommender system to correctly predict the objects that will be of most importance to the user based on a variety of methods. Accuracy in a recommender system has improved since the first study was published, but there is always room for the recommendations to be more accurate. In a lot of studies, the problem of accuracy is closely studied with another problem called data sparsity. Data sparsity is a problem that arises from the fact that, on average, users only give ratings to a small number of objects, and in a system with a very large catalog, the insufficient data makes it difficult to identify smaller users and objects. This negatively impacts the accuracy of recommendations by the system. Solutions to improve accuracy. One of the techniques suggested to improve accuracy is a Bayesian network model where user nodes, object nodes, and feature nodes are used to combine a collaborative filtering recommender system with a content-based filtering recommender system to produce more accurate recommendations. Research done on the context-aware recommender system has shown them to be more accurate at making recommendations compared to other types of recommender systems. From our tally, improving recommender system accuracy has been the focus of 16 studies. Scalability. Scalability is related to the number of users and objects that the recommender system must work with. A system is said to be scalable if it can handle increasing numbers of users and objects without slowing down or using excessive resources. A recommender system that recommends a few objects to a few hundred users will probably fail to recommend few hundred objects to a few million users if the system is not highly scalable. Some collaborative filtering recommender systems suffer from scalability issues because as the number of users in the system increase, the system needs to compare with increasing amounts of other users' recommendations to recommend an object to a user. Knowledge-based filtering recommender systems do not suffer from scalability issues as they do not rely on generated user profiles or object features, so an increase in users or objects in the system will not affect how recommendations are generated. Solutions to increase scalability. Multiple scalable recommenders have been suggested in studies. Hybrid is a recommender system that is designed to be highly scalable by combining a modified Pearson correlation collaborative filtering recommender system with a distance to boundary content-based filtering recommender system. The hybrid recommender system works by finding nearest and furthest neighbors of each user to reduce the size of the dataset. The reduced dataset means that the data that the system works on does not increase drastically with an increase in users, making it highly scalable. All studies have tried to improve scalability of collaborative and content-based recommender systems by combining them with each other and another type of recommender systems in some form. Diversity. Diversity has been identified along with accuracy as the most important property of useful recommendations. It helps avoid popularity bias that might arise in systems with many similar users and provide more diversified recommendations. It also tries to solve the overfitting problem where a user only gives feedback on certain types of objects such as haunted house movies. The system only knowing users likes this type of objects give recommendations to users from a very narrow spectrum of users' interest that they give feedback on. A user that has too similar or too narrow of a recommendation generated will get no benefit from them at all. Solutions to increase diversity. It has been suggested by a study into the diversification problem that using the k-furthest neighbor algorithm results in a more diverse recommendations. But user study conducted on that approach showed that the user perceived usefulness between diversified and non-diversified recommendation was little to nothing. Another study addressed the problem differently by using the ideas of experts, which act as the seed to generate diverse recommendations. The approach works by analyzing ratings of users in certain groups and promoting some users as experts of the group tests, and then the recommendations of these experts are used to generate the recommendation of the rest of the group. Here is a graph showing the frequency of recommender system problems addressed by all the study literature. As it can be seen, the cold start problem is the most prominent, followed by the sparsity problem and the accuracy problem and the scalability problem. Hybrid recommender systems. The literature on recommender systems use the term hybrid recommender system to refer to any recommender system that combines two or more individual recommender systems together in a variety of different ways. The combined recommender system need not be of different types. Studies have experimented with hybrid recommender systems created from the same type of recommender systems. However, most studies focus on hybrid recommender systems that combine different types of recommenders as they are the most implemented ones in real life and so the most promise in solving cold start, accuracy, and diversity problems. The most common types of hybrid recommender systems are weighted, switching, mixed, and cascade. Weighted. A weighted hybrid recommender system is possibly the simplest and most common form of a hybrid recommender system in which each individual component scores an object and the scores are combined using a weighted linear function. The reason why this is favored is in part due to the straightforward process, but also because it is easy to change the weighting of individual components to adjust the output of the hybridization. There are also very simple ways to eliminate many of the problems that arise using any individual recommender systems. Weighted hybrid recommenders have also shown to eliminate issues with cold start, accuracy, and diversity and scalability. Examples of weighted hybrid recommenders. One of the first weighted recommender systems was a Ptango that combined a collaborative filtering recommender system with a content-based filtering recommender systems to recommend online newspapers. It initially gives both systems equal weighting and gradually adjusts them as needed based on the user feedback. The weights are different for each user, so the system learns the optimal weighting for each user and alleviates the cold start problem as well as the gray sheep problem. A social media company uses a weighted hybrid recommender system of 3 collaborative filtering recommender systems. Unlike traditional collaborative filtering recommender systems, it does not require explicit ratings from users, but instead it uses tags so the objects such as photos can be recommended. A simplified structure of hybrid recommender system is shown in the figure here. First step is to provide objects recommendations is to generate potential candidates to recommend. In a weighted hybrid recommender system, all the individual recommenders jointly propose candidates for recommendations. Each individual recommender in the hybrid recommender system will rate the objects, and the linear combination of the individual ratings will be taken as the combined score of the object. Switching. A switching hybrid recommender system is one in which the system switches between different individual recommender systems to make the recommendation based on some criterion. This means that for different user profiles, different recommended types can be used. This is a popular approach to hybridization because research has shown that there is no one recommender system that performs consistently for every single user. If one of the recommender systems cannot make recommendations for a specific user with sufficient confidence, other recommender systems can be used. In this way, the switching hybrid recommender system can hedge their success. Examples of switching hybrid recommenders. An early example of the use of switching hybrid recommender systems in research is the Daily Learner, an online news recommender. It is made up of short-term content-based filtering recommender system and a collaborative filtering recommender system. More advanced research on the subject was shown using a complex mobile 3D GIS switching hybrid recommender system for tourists. The system uses a switching hybridization of the collaborative filtering recommender and a knowledge-based filtering recommender system for generations of recommendations. The 3D GIS location data is used to compute users' distance from the recommended tourist sites. The system then switches from one recommender system to another to reorder the recommendations based on the distance from user and recommends the sites that are the closest to the user with the highest accuracy. In all cases, switching hybrid recommender systems introduce additional complexity into the recommendation process in the form of switching criterion. Structure of the switching hybrid recommender. As you can see in the figure, a switching hybrid recommender system starts the process of generating recommendations by deciding which recommender to use based on the user profile and the switching criterion. Once the decision is made, the other recommenders play no part, and the candidates to recommend and the scoring for these candidates is done by the recommender chosen in the switching decision state. Cascade. A cascade hybrid recommender system is unique in that it is a type of staged recommender system. In it, one recommender is used to generate a list of possible candidates for recommendations, then subsequent recommenders are used to refine this list. This is done so that we can utilize multiple recommender systems but give them different priorities. This is not like a weighted hybrid recommender system in which all the recommender systems operate on the same entire dataset. In a cascade hybrid recommender system, recommendations in the later stage can only refine and not overturn the results of the recommenders in the earlier stage. In most cases, the secondary recommender system is used to break ties or rearrange the order of the candidates in the recommendation list. Cascade hybrid recommenders systems are sensitive to the order of the individual recommender systems, as recommenders in the earlier stage have more control over the final output. Examples of cascade hybrid recommenders. A well-researched cascade hybrid recommender system is Entree. It is used to recommend restaurants. It uses a cascade hybridization of a knowledge-based recommender system and a collaborative filtering recommender system. The issue with cascade hybrid recommender systems is that since the candidate list is generated by one primary recommender system, the weakness of the primary recommender system will also be present in the cascade hybrid recommender system. However, there are still benefits of using this type of recommenders when it is applicable to the use case. The major one is that the cascading allows the system to avoid using the later recommenders on items that the system already knows the user will be highly interested in. This avoids the clashes that occurs in mixed hybrid recommender systems. The structure of a cascade recommender system. The process of generating user recommendations starts with the primary recommender generating a list of candidates. These candidates are then scored by the primary recommender according to its rules. The secondary and subsequent recommenders then break the ties and reorder according to their rules, and then the score is combined at the end. Literature on hybrid recommender systems. All literature shows that the hybrid recommender systems improve on individual recommender systems by reducing their problems. Here we can see the most common one is weighted, feature combination, cascade, switching, and the other types. Gaps in literature. 50 academic literatures were studied for this survey on recommender systems. This gap in literature comes from the fact that the most research into recommender system is being done on very specific subsets of recommender systems, such as recommending movies or Amazon items. Other use cases need to be explored. Most studies were discussing recommender systems in the context of their projects and not in general. This means that the same type of problems are addressed over and over again. From this survey and other similar surveys on recommender systems that were done in the past, there is quite a big gap in hybrid recommender systems. Out of 41 possible combinations of hybrid recommender systems, only about half have been researched. It is unclear why there is a large amount of research on certain combinations but not others. So other combinations should also be researched. Future work. In most of the literature studied for this review, the leading proposed future work was to extend and improve the solution presented in the academic paper. In addition to that, future work should also focus on new systems to explore to see if there are any improvements on older systems. A well-known problem associated with popular recommender systems types is the scalability problem. It limits how much the system can handle before failing. Working towards reducing the resource cost of generating recommendations for large systems will enable the companies to see greater returns on investment and fix the scalability problem. Also, research should be done on the unexplored combinations of recommender system hybridizations to see if there are any new possibilities. Conclusion. In conclusion, we know that individual recommender systems have a lot of problems. Hybrid recommender systems have been shown by research to fix many of these problems and even improve on the problems in some cases. The type of hybrid recommender system that will need to be used will depend on individual use cases. Thank you for listening to my presentation.